Okay guys, so 4-2, solving systems of equations. Now we were solving systems in 4-1 by graphing them. This time we're going to use algebra. More specifically, we're going to use this thing called substitution. So what is substitution? Substitution is replacing a variable with something else, something that it is equal to. So here's a little silly example. Let's say this is our system right here. So we have an equation, 3x minus 8y equals 4, and we have another equation, y equals happy face. Okay, so instead of solving both equations at different times, we can combine them by replacing what they have in common, in this case, the y. So since the y is equal to happy face, what I can do then is take the first equation, 3x minus 8y equals 4, but now the y is replaced with the happy face. And it's the same equation because y and happy face are equal. They're the same thing. So when you plug it in, you haven't really changed anything. Then at this point, you would solve the problem for x. Okay? So this is substitution. And that's what we're going to be doing to solve these systems of equations. So let's go to number 1. Y equals x minus 6 and y equals 4t minus x. Now, they both have an x and a y in common, but I want you to notice what they're equal to. This one is equal to y, and this one is equal to y. So what that means is we can take this y and replace the y in the first equation with this. So what would that look like? So now this would be 14 minus x, that's my new y, equals x minus 6. So I basically took the y and I switched out y with 14 minus x. And now I can solve for x. So let's see, I have two x's, so I'm going to put my x's on the same side. So I'm going to add an x to both sides using inverse operations. Now I have 14 equals 2x minus 6. Okay, now I need the x by itself, so I'm going to have to get rid of this 6. Inverse operations, we're going to add 6 to both sides. So now I have 20, so I have 20 equals 2x. Okay, next step, what do I do? Well, I need to get rid of that 2. Let's get rid of that 2. That 2 is multiplying, so we're going to divide by 2. My answer for x is 10. X equals 10. Now here's the deal. That's only one answer. Remember, for these you need an x and a y. So we're going to take our answer and we're going to plug it in here. We're going to plug it into the equation. Now you could plug it into this one if you want. I just chose this one because it's first. It doesn't matter where you plug it in. So it's like substitution again. You're going to substitute x with 10. Substitute x with 10. Now you get this. What's 14 minus 10? 4. And there is your second answer. So you have your two answers. Now remember, this is two lines. And these two lines meet at this coordinate. What's the coordinate? 10, 4. So if you remember the graphing of these lines, we're always looking for where these lines meet. When you use substitution and plug in one into the other, you're solving for that point. You're getting the information for this coordinate, for that point, okay? Let's do one more. All right, now here, this was equal to negative 7, 2x plus 3, y equals negative 7. The first one, y equals 2x minus 1. Now this one's going to be a little bit different because I know that this is equal to y, so I'm going to have to take this one and I'm going to replace the y in here. I'm going to replace it with 2x minus 1. 2x minus 1 is y, so this is going to take the place of y. It's going to look like this. So 2x plus 3 times y equals negative 7. All right, now we got to do some work. We got to distribute. So 3 times 2x is 6x. 3 times negative 1 is negative 3. Okay, I have too many x's here, so I should combine my like terms, combine my x's. Okay, I'm going to move that 3. So we're going to do inverse operations. Now that it looks like this. Now we're going to solve for x by doing inverse operations. The 3's cancel out. I get -4. Now I have to divide by 8 both sides. Oh, I'm going to get a fraction. I'm going to get -1/2 or -0.5. So either answer is fine. Either of these answers is fine. But now remember, you now have to solve for y. Now I wouldn't plug this in here because I wouldn't solve for y by plugging it in here. But I could solve it in the first one. Why would I solve it into the first one? Because guys, this equation is equal to y. So if I plug in a number here and solve, I'm going to get my answer for y. So then this is going in here. So now it's going to look like this. X is -1/2, so 2 times x minus 1. So I multiply this, 2 times -1/2. This would be -2/2. You simplify it, that's -1. So -1 minus 1 is not 0, it's -2. So the point where these meet, my answer would be -1/2, -2. This is where these two lines meet. Okay, substitution. All right, let's do example number 2. Now, example number 2 is a word problem. So bear with me as I go to the word problem. Sorry, that was example number 3. Let me go to a blank page on my notes. Okay. So we'll use this side. On Saturday, a vacation resort offers a discount on water sports. To take surfing lessons and go parasailing costs $130. That day, 25 people take surfing lessons, 30 people go parasailing. The total of $3,650 is collected. What is the discount price? Okay, so if I take this information down, there's two things we're talking about. Talking about surfing and those lessons and parasailing. I think that's when you're on the board. I've never done parasailing. I've tried surfing, never tried that. Now, these two things have a cost. I don't know what they are. So I'm just going to put this as X and this one as Y. Okay, I don't know what they cost, but I'm going to give them variables. Now, if I did both lessons, it says it would cost me $130. That is my total. So remember, whenever you have a total, always set your equation equal to that number. Wait, there's another total in here. The total amount of money collected. They collected $3,650. But that total isn't about just doing 2 lessons. This total is about the day. Well, what happened that day? 25 people took surfing lessons and 30 people went parasailing. So this has 25 people paying this price, and this has 30 people paying that price. And that day, when they all paid, they paid this much. And these are my two equations. Okay, now there's 2 ways we can do this. One way is to do substitution. So guys, you would take one of these equations and replace it in the other. Now there's a problem here. The problem is this equation is equal to 130. It's not equal to X or Y. To use substitution, you would have to change it to be equal to Y so that you know what you can change Y into, or X. So what I'm going to do here is I'm going to move the X over there. And when I do that, this becomes my equation. So when I'm going to do substitution, the Y is going to change into this. So it's going to look like this. And here is our problem. Okay, so we would solve this. We'd have to distribute. Actually, it's going to be quite a bit of time to do this problem. So let me see. I'm going to say that's going to be 0, 0, 9, 3. So I multiply that, and I multiply this, and you get, use a calculator, guys. My like terms. All right, next, get rid of the 390. I'm gonna use inverse operations. I'll be left with negative 250. Last step here is I have to divide. So I'm going to divide 250 divided by 5, 50 bucks. Negative divided by negative is also positive. So x equals 50. So that's how much it cost for the surfing lessons. Remember all this? Oh, wait a minute. Let's plug it in because we got to find out this price. So if surfing is 50 bucks, how much is parasailing? Well, solve for y. Guys, how would we solve for y? Cancel out 50. Cancel out 50. Y is going to be $80. So my prices would look like this. Substitution. Now, I know that seems like a lot. So what I'm going to do right now is I'm going to show you how you could use Desmos to help you out on these questions, okay? So I'm going to open up Desmos, and I'm going to use Desmos graphing, okay? So Desmos calculator. Now, the way you can use Desmos for these questions is you can type in the equations in here. So remember what my equations were? I had one equation was y equals 130 minus x, okay? And then my other equation was the 25x plus 30y equals 3,650. Now, where's my answers? Well, you're too close to this graph. Let's zoom out. There we go. There's our two lines. Now, remember, when you're solving systems, you're finding the point where they meet, and ladies and gentlemen, right there, 50 and 80. Now I know, wait, we could have just done this? Yes, you could have just done this, but it's important that you know how to do it without the graphing calculator. This is also a good way to do it with your steps. So I encourage you to also double check your work with that. Okay, next, here. Let's, example number 3. I'm gonna work through these a little faster because of time. This one's equal to x, this one's equal to y. So you actually have a choice. You can decide to plug this one in here or this one in here. In this case, I'm gonna plug in x in here. So x, I'm gonna replace x with whatever x is equal to. So in this case, it's gonna be -4 minus y. Okay, now there's a negative sign in front. So what does that mean? Remember, whenever there's a negative sign in front, make that a -1. We're going to distribute -1. So your problem is going to look like this: +4, positive y, plus 5. Okay? All right. Oh, we have too many y's. Oh, but we have like terms too. So let's combine our like terms. And we're going to get y equals 9 plus y. But these two y's are bugging me. All right, let's move this y, so the y's can be together. And they both cancel out. What just happened? I have no answer for y. If y just canceled out, there's no answer for y. So what does this mean? Ladies and gentlemen, this means you have a no solution. Now, it's not just that your variables canceled out. What happened was your variables canceled out, and now your equation doesn't make sense. 0 is equal to 9? 0 is not equal to 9. If you get a statement like this when you're trying to solve it, and it doesn't make mathematical sense, that means that these equations will never cross. If you graph them, this would be parallel lines. Okay? All right. Here, this one. Okay, again, I'm going to use substitution for y this time. So I'm going to take y and put it in here. So it'll look like this. All right, now the issue I'm having here is there's parentheses, but there's no number in front. If you wanted to, you could put a 1 in here. But guys, if you multiply by a 1, here's what you get. 1 times negative 2x, negative 2x. 1 times positive 5, positive 5. What happened? They didn't change, right? Because it's a positive 1. Positive ones don't do anything. So you got this. Like terms, 2x minus 2x. And again, they canceled out. All right. But here's the difference. These canceled out, but my mathematical statement says that 5 is equal to 5. Wait, what happens? When you plug in the equation, you get 5 equals 5. That's what your equation says. That means that this is infinite solutions, or some people will write this all real numbers. Okay, so what does this mean? What this means is, since your statement makes mathematical sense, these lines are actually coinciding. These lines are the lines where you have one and the other one right on top of it, so they're always connected. So they're always meeting. So all the points are answers. So what you're always going to check for is if your variables cancel out, does your last statement make sense? Do you have the same thing on both sides or do you not? If you don't, it's not an equation because they're not equal. But if you do have the same thing, then your equation still works. And if the equation still works, then you have infinite. All right? Last example, and then we're done today, guys. Example number 4. Now, example number 4 is a word problem. An amusement park is charging $12.50 for admission and 75 cents per ride. So this amusement park is starting at $12.50 to get in. So that's your B. Remember, we're using MX plus B. We're still using lines. So MX plus B, you have to pay to get in. And then every ticket you buy costs you 75 cents. Oh, sorry, for every ride. I'm assuming it's tickets. There's a separate amusement park. They charge you $18.50 to get in. Amusement park that charges you $18.50 to get in, and they charge you 50 cents per ticket. So it looks like this. All right. For what number of rides is the cost the same at both parks? Basically, they're saying how many rides would you get on, and you pay the same amount. So this is kind of like the first example I showed you. If they're both equal to y, then you could take this one and replace it in the first one, and your problem would look like this. And you would solve for x this way. Then once you solve for x, you would also plug in your x and solve for y, and it doesn't matter which one you plug it into. What we're going to do right now is we're going to use Desmos one more time just to show you how to do that again. So let me go to Desmos. I'm going to get rid of these equations. Okay. I'm going to zoom back down, hopefully. Yeah, here we go. Zoom back down here. All right, and let's type in the equations. So y equals 0.75x plus 1250, and y equals 0.50x plus 1850. Okay, so you see that the first amusement park is cheaper until you get to here, right there. So what does that point mean? Well, x was rides. So x is 24 and y was the cost, $30.50. So what does this mean? If you go on 24 rides at each amusement park, they're both going to charge you $30.50. So at 24 rides, you would pay the same amount. So how do you make sense of this? Well, if you're going to not go on 24 rides, you should probably go to the first one because those were cheaper. But if you're planning on going on more than 24 rides, then you want to go to the second one because the second one will be cheaper after 24 rides. Okay? And guys, that is it. That is it for the lesson.